Hey, 21A students, here is me going over McDonough's practice final. I'll try to go over it the best I can and make any sort of observations or comments as we see here. Let's take a look. So first page starts off with some limits. Always good to read the instructions. Calculate the following limits. For any limits that do not exist, write infinity or negative infinity or does not exist. Yeah. So every time we have a limit, we start plugging it in first. If you can't automatically see it's 0 over 0. Here, if you plug it in, you get 9 minus 18. That's 9 over 9 minus 6 minus 3, which is a 0 over 0 type. You have choices here. Oh, actually, you don't have choices here, right? L'Hopital's rule is not on the table, so we have to factor and cancel. Yeah, L'Hopital's rule is not on the table. It's kind of a bummer. So limit as x approaches negative 3. Factoring in the top, you get x plus 3 times x plus 3. Factoring in the bottom, you get x plus 3 times x minus 1. I knew x plus 3 was going to be a factor because negative 3 made the top and bottom equal to 0. So an x minus 3 had to be a factor. Canceling out one of those, you get the limit. As x goes to negative 3 of x plus 3 over x minus 1. We plug in negative 3, we get negative 3 plus 3 over negative 3 minus 1, which is 0 over, doesn't really matter, 0 over not 0. 0. Cool. Here we plug it in, and you get the arc sine of negative root 2 over 2 over root 2 minus root 2 to the 4th. And that's going to be something over 0. Arc sine of negative root 2 over 2 is negative pi over 4. Right? It's the angle that you take sine of it, you get negative root 2 over 2. So now we have to figure out what's going on. Well, normally I would look at a limit like this from both sides. But I can see that since this negative root 2 minus root 2 to the 4th is raised to the 4th power here, no matter what's going on here, whether we're left or right of root 2, whether the bottom here is positive or negative, being raised to the 4th power is going to make it always positive. So we can say that this is going to be a negative infinity. Because whenever you have a non-zero number divided by 0, the limit is going to be either infinity or negative infinity, or it does not exist. And we get infinity, negative infinity when it's a negative positive. We get positive when it's positive, positive, negative, and then it does not exist if the two sides don't match up. So here we could do more work and say limit as x approaches root 2 from the right. I'm just going to write the function to make it easier. I know I'm going to get negative pi over 4 on top, and a number slightly bigger than 0 raised to the 4th power, which is negative infinity. Similarly, limit as x approaches root 2 from the left. You'd have a negative pi over 4 on top. You'd have a slightly negative number, but still raised to the 4th power means it's still positive. So that's why you're getting negative infinity on both sides. I'm having a hard time getting the words out of my mouth here. Okay, so this last one here. So I would rewrite this as, so I know it's 0 over 0, right? Sine 0 is 0. So I'm going to write this as the limit as t approaches 0 of sine 5t blank times blank over sine of 8t times blank spaces. And now I'm going to fill in the blanks. Here I love a 5t, and a 5t up there. Here I love an 8t, and an 8t down there. If you want, you can do one extra thing. You can write this as the limit as t approaches 0 of sine of 5t divided by 5t times 1 over sine of 8t divided by 8t times 5/8. And then limit of that's 1, limit of that's 1 over 1, limit of that's 5 over 8. So you get 5 over 8. Cool. Consider the function xy plus y squared equal to 5. Find the derivative in terms of x and y. So we're obviously being told here to use implicit differentiation. So using the derivative of xy, you're going to get product rule. So you get 1 times leave y alone plus x times the derivative of y is y prime. Derivative of y squared is 2 times y prime equal to 0. Solve for y prime. So leave this up on the left, bring that over to the right. So you have, and I would also factor out a y prime from these two things here. So I'm going to have y prime times x plus 2y equal to subtract y, divide by that, and you get y prime equal to negative y divided by x plus 2y. That's y prime. define y double prime, and right, you could write this y prime or dy dx if you prefer. D squared y dx squared is the derivative of dy dx, which we just found. So that's going to be the derivative of, sorry, that's a terrible parentheses there, negative y over x plus 2y. We're going to have to use the quotient rule. And that's almost always the case when taking the second derivative implicitly. So bottom, over here, times the derivative of the top, which is going to be negative y prime, minus the top, times the derivative of the bottom, which is 1 plus 2y prime, all divided by the denominator squared. If we go back and read the instructions, recall this means the second derivative of y as a function of x. The final answer does not need to be simplified, but it should not have any dy dx terms. So for every y prime, we're going to replace every y prime with negative y over x plus 2y. So write this as x plus 2y times negative y over x plus 2y. I might as well simplify that as a plus y times 1 plus 2 times negative y over x plus 2y. And if it says you don't need to simplify, you shouldn't simplify. You should just leave it like this. If you felt compelled to simplify, or if you were asked to simplify it, then I would move that this and that cancel. So I'd write this as negative y, plus I would distribute the y here and get y, and then y times 2 times negative y is minus 2y squared over x plus 2y, all over x plus 2y squared. And then if you really want to do more, you can multiply the top and bottom by x plus 2y to get, it's going to be 2y. You get 2y times an x plus 2y minus this times x plus 2y is just going to be 2y squared. And then finally, x plus 2y cubed, because they multiply the top and bottom by x plus 2y. And if you really want to finish it off, 2y times 2y is 4y squared, minus 2y squared is 2y squared, and 2y times x is 2xy over x plus 2y. You shouldn't do all this. You should stop right here. You get no extra points for simplifying it when it says do not simplify, or it does not need to be simplified. Okay. Consider the function. This problem is terrible. I was doing it the other day. I do not like it. It's my problem. Consider the function g of theta equals tangent of theta on the domain negative 3 pi over 4 to 3 pi over 4. I'm just going to point out that it'd be good to know what this graph looked like. So I'll point out that tangent has vertical asymptotes of pi over 2 and negative pi over 2. And then tangent of 3 pi over 4 is negative 1. And tangent of negative 3 pi over 4 is also negative 1. No, tangent of 3 pi over 4 is positive 1. Sorry about that. It kind of does this deal, right? It's the usual tangent shape. And by looking at it, you can probably note that there's not going to be any relative extrema. Now, I know they didn't ask us to graph this, but to me, it helps me figure out what's going on. So critical points, take the derivative is equal to derivative of secant squared theta. I might rewrite this as 1 over cosine squared theta. And then you're going to check where this is either 0 or undefined. Now, it's never equal to 0. And if you say where it's undefined, well, undefined, you're looking for where the denominator is 0. So set denominator cosine squared theta equal to 0. When you do that, you get theta equal to pi over 2 or negative pi over 2. Now, in my opinion, the correct answer to this, no, not my opinion, the correct answer to this question is that there are no critical values because to be, or critical points, because to be a critical point of a function, you have to be a value in the domain of the function. These are not. And then the derivative has to either be 0 or undefined there. So in my opinion, since these are not in the domain of g of theta, the answer is none. There are no critical points, which I think is a terrible answer, or I think it's a terrible question to ask. Find the critical points. There aren't any. I don't love that, but that's my bias. When is it concave up? When is it concave down? So going back to the first derivative, written as secant squared theta, or if you prefer secant of theta quantity squared, and my second derivative is going to be 2 times my stuff times the derivative of my stuff, which is 2 secant squared theta tangent theta. We know this is going to equal 0 when tangent's equal to 0, which is at 0, pi, 2 pi, but only 0 here. Equals 0 if theta equals 0. It's going to be undefined, again, at the same places. It's going to be undefined at negative pi over 2 and pi over 2. Unfortunately, they didn't ask us for critical points in the second derivative, so it's not like we need to say anything like, oh, these aren't really critical points. But they do ask us where it's concave up and concave down. So we're going to put all of these critical points. So even these ones that aren't really critical points are still places where the concavity might change. And it does. Over here, it's concave up. And then when we go to the other side of the negative pi over 2, it's concave down. So they are important to include. I do have an abbreviated number line because I'm starting at negative 3 pi over 4 and I need 3 pi over 4. So I'm going to draw it like this. Negative 3 pi over 4 not included. I'm looking at 0 and pi over 2 and negative pi over 2. So picking a number larger than between 0 and pi over 2 is that's easy for me to do. Like say, I don't know, pi over 4. Well, let's be smart about this. If you're in the first quadrant between 0 radians and pi over 2 radians, all three functions are positive. So 2 times secant squared times tangent is going to be a positive. So the whole thing is positive here. Picking a number larger than pi over 2, tangent's negative. Secant squared is always positive, so it's going to be negative over here. Similarly, over here in quadrant 4, where tangent's negative, 2 times secant squared times tangent is going to be negative because secant squared is always positive and tangent's negative. And finally, over here, where tangent's positive, you're going to have that it's all positive because secant squared is always positive and tangent of an angle there is positive. The function is concave up, concave down, concave up, concave down. And if you actually write out the intervals, you would say it's concave up on the interval from negative 3 pi over 4 to negative pi over 2, union 0 to pi over 2, and then concave down on the interval from negative pi over 2 to 0, union pi over 2 to 3 pi over 4. Looks all right. Okay. Alex fills a balloon with water at a constant rate of 3 cubic centimeters per second. Oh, I see a related rates question. Assume the balloon is perfectly spherical. How fast is the radius of the balloon increasing when the volume is 36 pi cubic centimeters? So we know that volume is equal to 4/3 pi r cubed. And we want to differentiate both sides of this because we are given that dv dt is equal to 3 cubic centimeters per second. We want to find dr dt. So take the derivative of both sides. Get dv dt equal to the derivative of 4/3 pi r cubed is 4 pi r squared times dr dt. Plug in what we know. We know that dv dt is 3. And we know that the volume, oh, that's annoying. How fast is the rates when the volume is increased, when the volume is 36 pi cubic centimeters? So that's an annoying way of doing this. Yeah, that's super annoying. So I guess we have to find the radius based on that. That's not lovely. So if we set 4/3 pi r cubed equal to 36 pi, pi's cancel. Let's divide by 4. 36 divided by 4 is 9, and then multiply by 3, so that's 27. So you get r cubed equal to 27, which means r is 3 centimeters. Okay, so we have 3 equal to 4 times pi times 3 squared times the thing we're trying to find, dr dt. So then, solving for dr dt, you're going to get 3 divided by 4 times pi. We should cancel the 3, but let's just say 4 times pi times 3 squared. So we get 1 over 4 times 3 is 12 pi. 1 over 12 pi centimeters per second is equal to dr dt. How fast is the surface area increasing at the same moment when the volume is 36 pi centimeters cubed? So great. So surface area is equal to 4 pi r squared. The rate of change of the surface area is equal to the derivative of that, which is going to be 4 pi times 2 times r times dr dt. Plugging in what we know that, well, first of all, 4 times 2 is 8, so we have 8 pi. You know, the radius is 3 centimeters because that's what the radius is when the volume is 36 pi centimeters cubed. And we know we just found dr dt from the previous part is 1 over 12 pi. So then 8 times 3 is 24. 24 divided by 12 is 2. So you end up with 2 centimeters per second. Centimeters squared per second. It's the area, not the length. Cool. Let's do the next one. Consider the function g of x equal to 1 over x plus 3x. What is the domain of x? Well, we have division, so we have to see where the denominator is 0. So we're going to say that x, we want to exclude x equal to 0. I would probably assume he wants you to write it using the interval notation. So I write this as negative infinity to 0, union 0 to infinity. Find g prime of 2 using the limit definition. So I will point out, I don't want to do it, I don't want to do the variable. I don't want to find g prime of x equal to limit as h goes to 0 of g of x plus h minus g of x over h. Not this. What I want to do instead is find g prime of 2 as the limit as h goes to 0 of g of 2 plus h minus g of 2 all over h. So let's plug in the things. So that's going to be the limit as h goes to 0. G of 2 plus h is going to be 1 over 2 plus h plus 3 times 2 plus h. And g of 2 is going to be 1/2 plus 6. And then finally h on the bottom. All right, let's simplify this out a bit. So distributing 3 here. I've got, and let's combine like things. So I'm going to write this as the limit as h goes to 0. I'm going to put the 1 over 2 plus h minus the 1/2 kind of together. And then I'm also going to have the 3 times 2, so 6 plus 3h minus 6. Now let's say that we have all that times 1 over h. And the 6's are going to cancel. And then we really need to get a common denominator here. So we're going to write this as the limit as h goes to 0. I'm going to multiply this by 2 over 2. You get 2 over 2 times 2 plus h. And multiply this by 2 plus, ooh, ow, my hand just went weird. Sorry. I'm doing too much writing. Multiply this by 2 plus h over 2 plus h. 2 plus h over 2 times 2 plus h. Plus, oh, sorry, we should go plus 3h all times 1 over h. Okay. So then simplifying this, 2 minus h, I'm going to have the limit as h goes to 0, minus h over 2 times 2 plus h plus 3h, all times 1 over h. And finally, I can factor out an h from both of those. All right, this is the limit as h goes to 0 of h times negative 1 over 2 times 2 plus h plus 3 times 1 over h. Those cancel. And then you have the limit as h goes to 0 of negative 1 over 2 times 2 plus h plus 3, which is going to be negative 1 over 2 times 2. Oh, sorry, I can't quite see that. So 3 minus 1/4, or prefer 2.75, or 11/5. Either way. I don't recommend checking this work, right? Like you can totally go back and take the derivative here and say, oh, the derivative is negative 1 over x squared plus 3, and then plug into you get negative 1/4 plus 3, which is exactly what we got here. But if you did it wrong, you might just be like, well, my work's pretty good, and I don't really want to go back and try and fix it. So I don't recommend checking it there. All right, looks like some optimization here. Someone's building a rectangular fence with one side facing north, one south, one east, and one west. For mysterious reasons, the portion of the fence facing north costs 20 for mysterious reasons. For reasons that make this problem more interesting. The north side costs $20 per meter. The south costs 30 per meter. The portion facing west east costs 50 per meter, and the portion facing west costs $200 per meter. The north-south edge of the fence are 5 meters long, and the east-west edge of the fence are 4 meters long. What is the total cost? That's a good question because it makes you realize how you're supposed to set up the next part. So I know that. So let's just draw this. So, right, this is 5 meters, 5 meters, 4 meters, 4 meters. And the cost is going to be, well, I know that the north side costs $20 per meter. 5 meters times $20 per meter. The south side costs $30 per meter. The east side costs $50 per meter. And sorry. No, that's right. And the west side costs $200 per meter. So our cost would be 5 times 30 plus 5 times 20 plus 5 times 30 plus 4 times 50 plus 4 times 200, which would be 100 plus 150 plus 200 plus 800, which is 1,250. Okay. So, what are the cost and dimensions of the cheapest fence this person can build if he wants to enclose an area to be exactly 20 square meters? So, we have these fence. It's called this side X, this side Y. We know the cost is going to be, well, instead of 20 times 5, it's going to be 20 times X. 20 times X, and then 30 times X, and then 50 times Y, also 200 times Y. And our constraint is that the area, which is equal to X times Y, has to be 20 square meters. So we're going to use that constraint to plug something back into over here. So let's simplify the cost equation. It's going to be 50X plus 250Y. And we also can say that this is going to give me Y equal to 20 divided by X. Or X, yeah, sure. Either way. So then this cost equation becomes 50X plus 250 times 20 divided by X. That's going to be 50X plus 5,000 X to the negative 1. Keep the derivative. 50 minus 5,000 X to the negative 2. So we end up getting 50 minus 5,000 squared 0. To me, it seems, oh, sorry, I can't quite see that. Apologies. To me, it seems obvious that the answer is X is 10, because if X is 10, the 10 squared is 100, and 5,000 over 100 is 50. You could solve this by getting a 50, there's lots of ways you can solve this. You can multiply this by X squared over X squared and say 50X squared minus 5,000 all over X squared is equal to then factor out of 50. And then you can say, oh yeah, X equals 10. Actually, technically plus or minus 10, we know negative numbers don't make sense. So anyway, so now to fully answer the question, we either have the X equals 10 meters. We can go back to Y equal to 20 over X and say Y is going to be 2 meters. And then the cost of the box, we have to plug in here and say the cost is going to be 50 times 10 plus 250 times 2. So 500 plus 500. So the cost is going to be $1,000. Cool. Definitely cheaper than the box we built over here. Yeah, I like that. That's a good question. I'm sorry, you can't. Sorry, I know I said words. And keep reading, keep things on screen. So we had X equal to 10, Y equal to 20 divided by 10, and the cost equal to 50 times 10 plus 200 times 2, which is 1,000. That's a good question. I like your question. Good job. Well done, McDonough. Way to write a good question. Okay, let f of t be this function. Find the derivative. Okay, f prime of t is going to be 4t cubed plus 12t squared plus 1. Find the minimum value on the interval. So we need to set this equal to 0 to see if there are any critical values. Now, the problem with this is setting this equal to 0 and finding the critical values is kind of a bummer. I wonder if that's not what he really wants you to do here. Well, anyway, let's think. So I know I'm going to have to find f of 0 and f1. So, I misread the question. What is the minimum value of the derivative on the? So to find the minimum value of the derivative, we have to find where the derivative has critical points. So we're going to find f double prime of t, which is 12t squared plus 24t. Set that equal to 0. If you factor out a 12t, you're left with t plus 2. Yeah. So you get t equal to 0, or t equal to -2. So what we know, in fact, let's just make the sign chart for the first derivative, even though we might not have to. We've got 0 and 2. Sorry, 0 and -2. Geez, I got those out of order. So let's say that's a -2 there. That's a 0 there. Sorry about that. So picking a number larger than 0, like 1, the second derivative is positive, meaning the first derivative is increasing, meaning the original function is constant about. And then between -2 and 0, you're going to get negative, so the first derivative is decreasing, and then from between the left of -2, it's going to be positive. So the first derivative is increasing. So specifically, from 0 to 1, f double prime is positive, meaning f prime is increasing. So the minimum value should be at the left endpoint if f prime is increasing. Let's check. So f prime of 0 is going to be 0 plus 0 plus 1. And f prime of 1 is going to be 4 plus 12 plus 1, which is 17. Anything else to say about that? And there's no critical value in between 0 and 1. Okay, part C. Sorry. So the minimum value is 1, which is f of 0. Prove there exists at least one value such that x between 0 and 1 and f of x is equal to 0. Okay, so that's back to the original function. Also, it's f of he changed it. So we should have said t a lot. So we know that f of 0, not f prime of 0, f of 0 is equal to -7. And f of 1 is equal to 1 plus 6 plus 1 minus 7, which is 1. Since f goes from a negative number to a positive number, we can end since f of x. So note, f of x is continuous. So by the intermediate value theorem, there must be a number c between 0 and 1 such that such that f of c is equal to 0. And that's what they want. They want at least one value x, we're calling it c. So that f of x is equal to 0. Prove there's exactly 1. Okay, so if there was more than 1, here's what would happen. So here's 1, here's 0, and let's say there's this point here, and this point. So there's more than 1, so the place with 0 there and 0 there. Well, first of all, that would mean the function would have to be decreasing somewhere between there, and we know it's just but let's pretend like it didn't do that. So then we're gonna say, okay, great. So your sum a and b in the interval from 0 to 1. So assume f of a equals f of b equals 0. Then there has to be a place between 0 and 1 where the derivative of the function is equal to 0 because of Rolle's theorem. So there must be c between a and b, which are in 0, 1, such that f prime of c is equal to 0. But f prime is equal to 12t times t plus 2. But we know from part B that the least possible value, the minimum value of f prime of t on the interval 0 to 1 is 1, which is bigger than 0. That's a contradiction, right? We said if there are two solutions, then there has to be a place where the derivative is 0, and then we're saying, but we know the derivative is actually the smallest value can be is 1. That means this assumption here is not true. So there cannot be two solutions. The one we found, the one we said existed is the only one. Okay. Last page. Bonus. Section 4.2, we discussed the corollary of the mean value theorem, which says if two derivatives are equal to each other at every point, then there exists a constant c such that the functions differ by a constant. Cool. The functions natural log of x and g of x equal natural log of x seem to constitute this conclusion. They don't. In particular, by the derivative techniques we used in class 1 can show that f prime of x equal to g prime of x equals 1 over x. Explaining why this doesn't lead to a contradiction with the corollary. So here's the deal. So if the derivatives are the same, so if f prime of x equals g prime of x equals 1 over x, then we should be able to say that f of x is equal to g of x plus c. And it does, because, sure, yeah. Yeah. So I would say that f of x is natural log of x, and g of x being the natural log of 2x is really the natural log of 2 plus the natural log of x. The natural log of 2 is a constant. So f of x, right, is equal. I mean, I guess it's kind of, I don't love the way that this is phrased exactly, but essentially, yeah, f of x is equal to the natural log of x, which is equal to g of x plus c. I feel like that's kind of backwards from how he probably meant for it to be, but that's kind of how it is. So here's my f of x, and here's my g of x plus c. So they really do differ by a constant. Kind of funky. And then here, find constants a, b, c, and d such that this function satisfies all three of the following properties. F of 0 equals 0. So the only thing that matters for f of 0 to be 0 is that, so f of 0 is going to be equal to 0 plus 0 plus 0 plus b plus 1 over 0 plus 0 plus d. We want f of 0 to equal 0. That means b has to equal negative 1 over d. Okay. We'll do more of what we can. And then has two vertical asymptotes, x equals 7, x equals 1. So to have vertical asymptotes at 7 and 1, we need this bottom part to factor as x minus 1 and x minus 7. So we need x squared plus cx plus d to equal x minus 1 times x minus 7, which is x squared minus 8x plus 7. So great, we've got d equal to 7. We've got c equal to negative 8. And we've got b, so equal to negative 1 over 7. So b equals negative 1 over 7. C equals negative 8. E equals 7. Finally, I have to have a critical value of 4. To take the derivative of this garbage, it's equal to 0, and then solve for x equal to 4. That's going to be gross, but we're almost there. So I'm going to plug these points in. So I'm going to have the f prime of x is going to equal 3x squared plus 2ax minus 24. Derivative of b is 0 plus the derivative of 1 over x squared minus 8x plus 7. I guess I would write it as x squared minus 8x plus 7 to the negative 1, and then the derivative would be negative 1 times that to the negative 2 times 2x minus 8. Cool. Okay. So this actually isn't so bad. So really we just have to make sure that this turns out to be 0 when we plug in 4. So notably, when I plug in 4, that part's going to be 0. So I need to plug in 4 and get 0 here. So I plug in 4, 3 times 4 squared, plus 2 times 4 times x minus 24. Sorry, 2 times a times 4 minus 24 has to equal 0. So 8a, 3 times 16 is 48, minus 24 is 48, minus 24 is positive 24. So it looks like a is going to have to be negative 24 divided by 8, which is negative 3. Those are our numbers. Cool, that test is not too terrible. Hopefully his actual exam looks very similar to his practice exam. Good luck on your final. I'll be in drop-in later today from 1 to 3, and then tomorrow from 10 to noon and 1 to 3 again. And then Wednesday and Thursday, same. All right, good luck. I'll see you all later. Bye.